Nobel Laureate Adam Riess has suggested that our understanding of the universe may be fundamentally flawed, and he's far from alone. In the wake of groundbreaking observations from the James Webb Space Telescope, a growing number of leading scientists are now warning that the cosmos is far more bizarre than we ever imagined. Not long ago, we talked about Xulong, the largest Milky Way-like galaxy ever found, which formed impossibly early in cosmic history. Its existence alone shook the foundations of galaxy formation theory. But now, the James Webb Space Telescope has revealed something even more troubling. This new finding isn't just unexpected, it's profoundly unsettling for modern astronomy. Astronomers have identified an enormous barred spiral galaxy called JADES-GS-z14-0, dating back 11.1 billion years, when the universe was only about 1/5 of its current age. Observations from the ALMA Observatory and NASA's James Webb Space Telescope show that JADES-GS-z14-0 possesses a clear spiral shape and a central bar strikingly similar to the Milky Way's. Yet it dwarfs our galaxy, boasting more than 10 times the mass and producing stars at a staggering rate, roughly 300 times faster than the Milky Way. What makes this discovery truly shocking is its level of order. JADES-GS-z14-0 appears highly organized during a period of cosmic history when galaxies were expected to be messy, unstable, and chaotic. Even more puzzling, despite its extreme star-forming activity, there are no signs of mergers or violent collisions, processes that usually drive such behavior in galaxies today. Its calm, solitary formation during such a violent era directly contradicts everything we think we know about how galaxies are supposed to grow. But that's not all. Beyond this, the James Webb Space Telescope's deepest ever view of the universe has sparked an intense and growing debate among scientists. This extraordinary observation required more than 120 hours of exposure, making it the longest Webb has ever stared at a single region of space. The resulting image reveals swirling arcs of light, ancient galaxies dating back to the cosmic dawn, when the universe was only a few million years old. And within this image, researchers notice something deeply unsettling. The farther we peer into the early universe, the more baffling and unexpected the discoveries become. Scientists once believed Webb would simply show us how the universe looked shortly after the Big Bang, how the first small galaxies formed and slowly evolved into larger ones over billions of years. Instead, what Webb has uncovered at the very edge of cosmic history has sent shockwaves through astronomy. An increasing number of researchers are now suggesting that it feels as though we're glimpsing an entirely different universe, one dominated by massive galaxies and strange cosmic structures that blatantly defy the predictions of our current theories. So what did Webb actually uncover in its latest observations? And why are scientists now wondering if it's revealing a universe that looks nothing like what we expected? To understand that, we need to rewind to 2016, when NASA's Hubble Space Telescope made a historic discovery. Hubble identified a galaxy known as GN-z11, which instantly became the most distant and oldest galaxy ever observed at the time. Its light had traveled for 13.4 billion years to reach Earth, allowing astronomers to see it as it existed just 400 million after the Big Bang, when the universe was only about 3% of its present age. But distance wasn't the only thing that stunned researchers. GN-z11 was far brighter, larger, and more actively forming stars than anyone expected for such an early era of cosmic history. According to standard cosmological models, a galaxy this massive and developed simply shouldn't have formed so quickly. Even so, many scientists treated GN-z11 as an outlier, a rare cosmic anomaly. After all, most of the other galaxies Hubble observed at similar distances, up to a redshift of 10, lined up neatly with existing theories. There was little reason, at the time, to seriously question the prevailing models. That sense of confidence didn't last. In 2022, the James Webb Space Telescope began its science mission, built specifically to peer deeper into space and further back in time than any telescope before it. Almost immediately, Webb started delivering the unexpected. In its very first deep field image, it revealed multiple galaxies that shattered previous records for both age and distance, opening the door to a wave of new questions about the early universe. One of these discoveries, known as JADES GS-z14-0, appears to have existed just 350 million years after the Big Bang, making it even older than GN-z11. The announcement sent ripples through the astronomy community. If GN-z11 wasn't a one-off, and multiple galaxies that were similarly bright, massive, and fully formed were showing up this early, then something much deeper was at play. It suggested that our current picture of how galaxies form and evolve might be fundamentally flawed. As the Webb Space Telescope kept observing, the mystery only deepened. It began uncovering objects at even greater distances, objects so bright and so enormous that astronomers aren't entirely sure what they're looking at. Are these true galaxies, supermassive black holes, or something completely unknown? Whatever they turn out to be, they don't fit within any existing theoretical framework. Some of these objects seem to have formed as early as 300 million years after the Big Bang, or possibly even earlier. The problem is stark. Our standard cosmological models simply don't allow enough time for structures this large and luminous to exist so soon. For a time, the title of the most distant and oldest known galaxy belonged to JADES GS-z14-0, which dates back to roughly 290 million years after the Big Bang. Even that discovery left scientists scratching their heads, as its sheer size at such an early epoch pushed the limits of what current galaxy formation theories can explain. But just when it seemed like Webb had already rewritten the record books, it delivered yet another surprise. Astronomers identified an even more extreme object, named MOM-Z14, dating back to just 280 million years after the Big Bang. With a redshift of 14.44, MOM-Z14 overtakes the previous record holder, JADES GS-z14-0, which had a redshift of 14.32. Each new discovery pushes the boundary further back and raises even more questions about what we thought we knew about the early universe. This discovery pushes far beyond what our current understanding of the early universe can explain. Scientists still aren't sure what they're actually observing. Is it a galaxy, a black hole, or something entirely different? Whatever the answer turns out to be, existing models say it simply shouldn't exist this early in cosmic history. And importantly, the hunt for massive early objects doesn't stop at a redshift of 15. Researchers have now identified a substantial population of galaxy candidates at redshifts between 15 and 30. Some of these objects show multiple possible redshift measurements, meaning their distances will need to be refined through further spectroscopic observations. Still, several remain strong candidates for redshifts well beyond 15. According to recent studies, even if only a portion of these candidates are confirmed at such extreme distances, it would place serious strain on current theoretical frameworks. With each new finding, astronomers are uncovering galaxies that are not only far more massive, but also surprisingly complex, rivaling or even exceeding the structure of the Milky Way, yet appearing just a few million years after the Big Bang. The sudden arrival of these bright, well-organized galaxies in the infant universe is forcing scientists to ask difficult questions. Their existence suggests that the cosmos may be far more unexpected than we ever assumed, especially as we push deeper into its earliest epochs. Many researchers now argue that standard cosmological models do a good job of describing the universe's evolution up to a redshift of about 10. But beyond that point, when we peer into the universe's first moments, the picture begins to change dramatically. So far, no existing theory can fully account for what Webb is revealing in those initial few million years after the Big Bang. And it's becoming clear that this mystery goes far beyond galaxies simply forming earlier than we thought possible. Scientists have also noticed that the universe isn't expanding at a perfectly steady rate. This points to something even more unsettling, that dark energy, the mysterious force thought to be driving cosmic expansion, may be changing over time and gradually weakening. If true, this directly challenges one of the central assumptions of the standard cosmological model, that dark energy is constant. In a way, it even calls into question one of Einstein's key ideas, that the cosmological constant truly is constant. Taken together, these discoveries hint at something deeply significant. It may be that we're missing a fundamental ingredient in our understanding of the universe. Or perhaps something unusual happened in the universe's earliest moments, something our current theories simply don't account for. Right now, our models offer no clear explanation. Even when we push our telescopes to their limits and look back just a few 100 million years after the Big Bang, we're already seeing objects that shouldn't exist yet. We're observing what appear to be some of the very first galaxies ever formed, and astonishingly, some of them already contain supermassive black holes at their centers. That fact alone underscores the problem. There is very little time between the Big Bang and the formation of these early galaxies, yet somehow, within that brief window, nature managed to create supermassive black holes weighing millions or even billions of times the mass of the Sun. Explaining how such enormous structures could form so quickly remains one of the biggest unanswered questions in modern cosmology. For decades, by studying the nearby universe and tracing its history all the way back to the cosmic microwave background, scientists concluded that everything began with the Big Bang, a state where the universe emerged from an extremely hot, infinitely dense point. But the surprising discoveries made by the James Webb Space Telescope are now pushing researchers to re-examine that long-standing picture. The appearance of massive, well-organized galaxies only a few 100 million years after the Big Bang doesn't sit comfortably with standard cosmological models. Because of this, some scientists are beginning to explore ideas that go beyond the traditional Big Bang framework. One possibility suggests that our universe may not be the first, that other universes could have existed before ours and may have even interacted with it during its earliest moments. More speculative theories go even further, proposing parallel universes dominated by dark matter, potentially linked to our own through extra dimensions, as described in string theory and brane cosmology. Another intriguing idea is that of a mirror universe, one that runs backward in time, existing as a symmetrical counterpart to our own cosmos. Among these concepts, one theory attracting growing attention is conformal cyclic cosmology, or CCC, developed by the renowned physicist Sir Roger Penrose. In this model, the universe is part of an endless sequence of cosmic cycles, where each universe is born from the remnants of the one before it. Penrose has even suggested that faint traces of a previous universe might still be detectable in the cosmic microwave background, subtle patterns that could carry echoes of a pre-Big Bang era. Interestingly, some of the early galaxies revealed by the James Webb Telescope appear to be consistent with predictions from models like CCC, lending weight to the idea that our universe may be far older or far more complex than we ever imagined. If you found this exploration interesting and informative, let us know your thoughts in the comments. We'd love to hear from you. Thanks for watching.